So today I'm going to look at another practical demonstration. We're going to look at a couple of reactions of copper to sulfate. So copper 2 sulfate comes up quite a lot in various experiments. You can see here I've got a bottle of copper 2 sulfate. I just want to point out it says 5H2O on it. That means that this is hydrated copper 2 sulfate. So for every molecule of copper sulfate there is 5 molecules of water trapped inside of its crystal structure. So I'm just going to place some copper 2 sulfate in here. I'm not going to measure it out. As we can see, hydrated copper 2 sulfate is this lovely blue color that we've got here. Just put some into that boiling tube there. Okay, so the first thing that I'm going to do is I'm going to heat the copper 2 sulfate. And if you heat a hydrated crystal, what happens is you are going to remove the water. And this is an example of a reversible reaction. So this can actually be used to test for water, because when it's got water in it, it is this blue color. And when it is dry, you can see it's starting to dry out there a little bit. When it's dry or anhydrous, then it becomes a white color. So I am just heating it here to remove the water of crystallization. I'll put the equation for that on the screen now. We can see coming out the end is water vapor. You can see the water there is beading and collecting on the side of the boiling tube there. There was no liquid water in this tube when I started. It was a dry tube. That water is water that was inside. Oh, lots of lovely steam coming out there. Water vapor, not steam, water vapor. Lots of lovely water vapor coming out, showing that there was quite a lot of water in the hydrated crystal there. Okay, so that shows us that this was hydrated and contained a large amount of water. The white solid that you could see there is anhydrous copper 2 sulfate. So that's without the water. So this is a hydrated salt that is blue color when hydrated and white color when anhydrous, or when the water has been removed. So that is a common experiment. It's used to test for the presence of water. You can use the anhydrous stuff, the white stuff, drop a liquid that you think is water onto it and it will go blue. It's also an example of a reversible reaction. So you can see that there. So lovely white color there. I haven't heated it all the way through, so there's still a little bit of blue in the middle there. We can also see the water vapor coming out here, showing that there was water trapped inside of those crystals there. So anhydrous copper 2 sulfate is white, hydrated copper 2 sulfate is blue. This is now later. What I'm doing here is I've allowed it to cool, and I have a thermometer which I'm going to put into the cooled down to room temperature copper 2 sulfate. It's the same stuff from before. This is the anhydrous copper 2 sulfate. It is cooled down to room temperature. If I can get it to focus there, we'll see that room temperature is about 23 degrees Celsius there. So this is anhydrous copper 2 sulfate at a temperature of about 23 degrees Celsius. And what I'm going to add is distilled water. So this time I'm doing the reaction backwards to what it was before. Previously water came out, now I'm going to add water in, and we should see a couple of changes. Firstly, put a few drops in here, it's going to change to a blue color, and that blue color, some of it's dissolved there, so I'm actually getting a blue solution. That blue color tells us water is present, but what's very interesting, the temperature is rising. So we can see it started as 23 degrees Celsius, it's just hit 40 degrees Celsius there. And that's because the forwards reaction was endothermic. I put energy in, I put heat in to make that reaction happen. The backwards reaction, when I put the water back in, is exothermic. It releases heat. Alright, thanks for watching.